Hello guys, today we're going to study 3.1 quadratic functions. The first question is, what is a quadratic function? Let's take a look. Let me just go ahead and write it down. We're just going to say the form of f of x equal to ax squared plus bx plus c, where our a cannot be 0 and a, b, c, they are all real numbers. Alright, this is just the way to write it in math. That means a, b, c are all real numbers. So please make sure don't mix this with the ax squared plus bx plus c equals 0, because that is a quadratic equation. So today we're dealing with quadratic function. Alright, so let's take a look at the graph. So if we have a f of x equals ax squared plus bx plus c, if our a is greater than 0, that means we are going to have a parabola opens upward. Okay, and then we also want to know each term, how we call them. This is a symmetrical, and this is called the axis of symmetry. And then this point is called the vertex. In this case, it's a minimum, right? From this graph, that will be the minimum point. Let's look right here. So as you can see, so that is your vertex. But this time, that will be called maximum point. So then we have, in this case, we have a is less than 0, and then we have, look, this parabola opens downward. Okay, let's also take a look at what is the standard form of a quadratic function. So I write it right here for you guys. It's very important you know what is the standard form of a quadratic function. We have a standard form, so that's the a cannot be 0. So we say is the vertex, in this case is the hk, and the axis of symmetry is x equals h. And then if a is greater than 0, then is upward. If a is less than 0, it's downward. So you really need to remember this. Okay? So we remember a couple things. This is your standard form, and then this is your vertex, and then we have axis of symmetry, and then this I think is really easy to remember, so I'm not going to highlight this. Alright, let's take a look at example 1, graphing a quadratic function in standard form. We make sure we know what's the standard form. So f of x equals to a parenthesis x minus h close parenthesis squared plus k. Okay, that is very, very important. Let's say, for example, if this question give you something like this. They give you f of x equal to 16 minus x minus 1 squared. Okay, so make sure when you do this type of question, you always want to do is you want to rewrite this to the standard form first, then graphing it. So in our example 1, so it's already in the standard form, so we don't have to rewrite it in standard form. Okay, your homework sometimes will give you something like this, then you have to rewrite it like it f of x equal to negative x minus 1 squared and plus 16. So you have to rewrite it to standard form. Okay, let's go ahead and take a look at graphing this. Okay, f of x equal to negative 2 x minus 3 squared plus 8. So step 1 we're going to do is we're going to find our a, h, and k. Okay, remember the standard form. Let me just rewrite this again. The standard form is f of x equal to a x minus h squared plus k. I just want you to go ahead and take a look. So from here, I'm going to know our a is negative 2. I'm going to compare our h is equal to 3. And our k is equal to 8. And then I'm going to write it down. So step 1, so we find our AHK. Also, what we're going to do is we're going to figure out is the a is greater than 0, less than 0, so which one? So then we can know, because we said if a is greater than 0, so we're going to have a upward, right? So if a is less than 0, we're going to have parabola go downward. So in this case, our a is -2, which is less than 0. So that means our parabola is actually go downward. So I'm going to write down right here, that's our step 1. Please make sure you actually know how to do this. I know the fact is you can use your graphing calculator, just graph this, and then you're done. However, you must show work on your quizzes and tests. Otherwise, you will receive 0 points. So please make sure you need to know how to graph it by hand. And then our step 2, find the vertex HK. So in our case, we already saw what is H and K, so I'm just going to write it down. Vertex is H is 3 and K is 8. So that is my vertex. And then let's go ahead and work on step 3. Find the x-intercepts by solving f of x equals 0. Go ahead and set this whole thing to 0. -2x minus 3 squared plus 8 equal to 0, but I'm just going to write 0 to the right hand side so that is easy for us and to solve it. So let's go ahead, this is a basic algebra. So we have 8 right here. We'll go to another side, the positive go to become negative, or you can subtract 8 both sides. Once we have here, so we can go ahead and divide by -2 both sides. We cancel -2 out, so we're going to have x minus 3 squared equal to +4. So once we have +4, so we're going to take a square root of both sides. When we take a square root of both sides, we always have to remember you get positive and negative. So then here we're going to have a square and a square root. They're going to be canceled out. We have x minus 3 equal to positive -2. So then we can do is we're going to add 3 both sides. So you're going to have x equal to, or you can think of this, go to another side, become positive 3 plus -2. Then we can separate this to have x equal to 3 plus 2, and then we have x equal to 3 minus 2. So in this case, we have x equals 5 and x equals 1. X-intercepts are 5 and 1. So that means the parabola passes through 5, 0 and 1, 0. So it's something important I want to mention. For step 3, if you try to solve it, if you get no real solution, it means there is no x-intercepts. That would look like something like this. Okay, no x-intercepts, like something like this, right? For step 4, we're going to find the y-intercept by computing f of 0. So let's go ahead and take a look. So let's go back and look. We're just going to take a look at what was the original function. F of x equal to -2, x minus 3 squared plus 8. Okay, so what we're going to do is we're going to compute, or you can say we're just evaluating f of 0. So plug in 0 for x, and then we're going to have -2, 0 minus 3 squared plus 8. So then we're going to get -10. Okay, you can do step by step. So then we're going to say the y-intercepts at the points 0, -10. Step 5, now we're going to graph. Here we have the graph. Okay, here is on the right side everything we have found so far. So we're going to go ahead and just follow this, draw the graph. So this is my vertex, 3, 8. And we know this is going to go downward. So here we have 1, 0, then we have a 5, 0. We also have a y-intercepts, 0, -10. It's right here. So then from all this information, because we know this is a vertex, that also implies right here is our axis of symmetry, right? So just in case you forgot, axis of symmetry, which is x equal to h. In our case, h is 3, so we're going to have x equals 3. Alright, let's go ahead and make this graph. I'll try my best. Okay, that's not bad. Alright, so again, make sure you actually know how to show our work. Very, very important. Okay, before we move on, let's make sure we know what's domain and range. So in this case, if you look at domains, always remember when we talk about domains, so we're just look at the left and right, okay? So basically we're just looking our x-axis. So in this case, if you think about this, so you can extend this side as well, correct? That means from the left it goes to right, so this goes to go down forever. So when you look at your x-axis, matching this right here, so let's say this goes right there, so eventually we can go forever. That means your domains from negative infinity, alright, same thing as this side, the graph goes down forever. So that means if I extend this, it's the same thing, same exact thing happens, right? So I find that so many students get, really get confused right here. So you have to observe the graph, then you match your x-axis. Is it going to get greater forever? So the answer is yes. Then you have to write your domain is from negative infinity to infinity. Okay? So you look your left to right. So then what is the range? When we're talking about range, so we're talking about up, down. So we always want to from down to up because we want smaller number. Always write smaller number first. So if this is if you look at up, down, then you observe your y-axis. What's happening is you can go down forever. So that means your range is from negative infinity, alright? So from here, I can go up, 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 up. So we have to, the maximum, we have to stop right there. So what is that? That is 8. Do we include 8? Alright, it's a solid circle right here. That means we have to include 8 brackets. That is how we do the domain and range. So you can do some homework and then go ahead and practice a little bit more, then ask me questions anytime. So example 2 is a very similar question. So let's go ahead and do a little bit faster. Alright, step 1. So we check, make sure it's in standard form. In this case, yes, it's in the standard form. And then we check what is my A. So my A is 1 because the standard form, let me just write it down again. So I'm going to match this because this here have an invisible 1. A equals 1, which is greater than 0. And then that means our parabola is going to go upwards, right? Because it's positive. Then step 2, we want to find the vertex. The vertex, remember, is HK. So in our case, our HK right here, be careful, this is a plus right here, here is a minus, which means our H is negative 3. Then our K is 1, right? Because here we have to rewrite this as x minus negative 3, then that match our standard form right here. So our vertex is negative 3, 1, so that is my H, this is my K. And then step 3, what we have to do is we find the x-intercept by solving this equation. So we're going to have x plus 3 squared plus 1 equals 0. Okay? So we want to solve this, then we move it around, x plus 3 squared equals negative 1. So when I try to solve this, I take the square root of both sides. What happens right here is I take square root of both sides, positive and negative. Then we're going to have what? X plus 3 equals to positive negative I. So my x equals to negative 3 plus minus I. So recall, when we have this, that is not real solution, which means there is no x-intercepts. So we mentioned earlier. So let's go ahead and continue this. We said step 4 is we finding the y-intercept by evaluate f of 0 equal to, we just put a 0 for x, that will be 0 plus 3 squared plus 1. In this case, give us what? This is 3 squared and 9 plus 1 is 10. So that means your y-intercepts is 0, 10. But once we have this, if we want to, it's not necessary, But if we want to, we can find the axis of symmetry, right? It's just x equal to h. So x equal to -3, that is your axis of symmetry. And step 5, we're just going to graph it. So let's go ahead and just graph it on the right side. I'm going to graph it really fast. So we know this is going to be upward. We have vertex -3 and 1. So we're going to have 1, 2, 3. So that's -3 and +1. So right here, right? So we know it's going upward. So we look at the y-axis. Let's look at y-intercept 0, 10. All right. So we have, let's just go ahead. We have a 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So your graph is something like this. All right. So you got to the idea. Okay, that is 0, 10. So if you look at this graph, obviously it's not perfect. It's far from perfect. So you can see there's no x-intercepts, correct? So there's no x-intercept, and then we have upward. So then we also know this is your axis of symmetry. That is x equal to -3. So everything looks good. So you're done. So let's practice the domain and range. In this case, domain, again, if you look, is, you know, always actually, if you look at problem, always they're going to have domains negative infinity to positive infinity, because this extend this forever on the left side, extend this right side forever. Okay? And then we also look at range. Range, make sure always from the smaller number that goes up, alright? From the lowest and goes upper. In this case, we have actually have the right there, there's the points, right? That is your vertex. And then that means your range is from 1, actually we have to include 1, and then it goes up forever, so it's from 1 to the positive infinity. So that is our domain and range. Alright guys, let's look at last example. This example actually is from your homework. It says write the equation in standard form with the same shape of f of x equal to 9x squared or g of x equal to -9x squared, but with the given max or minimum. In this case, it's a maximum equals 8 at x equals -7. So before we do this, we have to recall from previous lessons. So we have learned about the transformation. So let's go ahead and recall this, okay? Transformation of f of x equal to ax squared. Alright, so we transform this then to the standard form f of x ax minus h squared plus k. So if you look at this, we actually from here we can tell that was moved to the right. So we're talking about our h is greater than 0. Alright, this is a positive number. And then here plus k, we assume the k is greater than 0, positive number as well. So that means we're going to move up in k units. In this case, we have move up in k units. Let's go ahead and take a look at this. So since we're talking about maximum, so you have to recall really beginning of the lesson. So we had a graph when our a is greater than 0, right? So we have something graph like this. So that means you actually produce a minimum. So when we have a downward right here, we produce a maximum, which in this case we're going to have a less than 0. So we know we're going to have a maximum right here, which means our a must be less than 0. So we look at f of x is a is greater than 0, so we must use the g of x. G of x equal to -9x squared. Because our a in this case is -9, that is less than 0. That is the only way we can produce maximum. So once we have this, we also know is the vertex is given to us is right here, because we're dealing with this graph right now, right? We're dealing with this right now. So from the given information, we're going to have our maximum equals 8 at x equals -7, which means if our vertex is -7 and 8. Okay, once we have all this information, we can easily write, let's go ahead and write this as h of x. Well, let's not repeat the letter, okay? Let's write h of x equal to, because I know the standard form right here is ax minus h squared plus a k form, I'm going to rewrite this as our a didn't change, right? So I can write x plus 7 squared and plus 8. Then you're going to say, why is it plus 7? Because the form, alright, I'm going to write it below just in case you didn't understand. F of x equals ax minus h squared plus k. If you look at this, we have negative, and here our vertex is also negative 7. So we have to rewrite this actually as x minus -7 form. Then we simplified it, we're going to have x plus 7. And then k, we have 8. So basically, that is how we found everything. Okay guys, thank you for watching the video. I'll see you guys next time.